Hello there, eighth graders. Happy Monday. Before we begin here, I want to make sure that you have a couple of things. Make sure that you have a pencil and paper. Make sure that you have a drink of water or something to drink while we do this, and make sure that you have access to a calculator, whether that's on your cell phone, an actual calculator, or your Chromebook. Make sure that you have all of those things before we begin. So pause the video, go and do that. But as we begin here, I just want to say happy Monday. Appreciate seeing y'all here today. And I really do thank you for watching these videos. Thank you for working with me here as we get through this distance learning experiment. Some of you are loving it, some of you are not, and I understand. Just wanted to say I really appreciate it. We're over halfway done. We're on week 6 of our 10 weeks. And guys, we're doing it. You guys are being rock stars here. I really appreciate your guys' gumption. That's the word that I'm looking for. You guys have gumption right now. That's stick-to-itiveness, right? Where you're sticking to it, where you're trying your best. I really do appreciate that. So if you need me for anything, Google Hangouts or email me. I'll be able to help out there. But we are going to focus today on deriving and using the Pythagorean theorem. Now, Pythagorean theorem, I don't know if this is something that you might have covered in 7th grade. It's something that I think you start to touch on, but it is not something that we definitely get into at younger grades. This is definitely a 8th and 9th grade topic. Might be a little difficult, but I promise you it will be easy to understand once we practice a little bit. Okay, so without further ado, let's just jump into it. So deriving and using the Pythagorean theorem. Tracy's kitten is stuck 2.8 yards above the ground in a windowsill of her grandma's house. Her grandma is not at home, so she decides to rescue her terrified kitten with the help from her friends. For safety reasons, the base of the ladder must be 0.7 yards away from the house and extend 1 yard above the windowsill. The ladder she borrowed was 4 yards in length. Tracy positions the ladder in place. She looks up and wonders if the ladder is going to be tall enough for her to rescue her kitten. To do this, we are going to use the Pythagorean theorem. So, ladies and gentlemen, we've learned about our angles and our triangles. Triangles are often named according to the measure of the angles they contain. An acute triangle has 3 angles such that each of the 3 angles are less than 90 degrees. We know that. An obtuse triangle has 2 angles such that the measure of each of these angles is less than 90 degrees, but the third angle is greater than 90 degrees. We also have a right triangle. A right triangle has 1 angle that has a measure of 90 degrees and 2 acute angles, so that of their sum measures 90 degrees. 2 acute angles of a right triangle are complementary. They both have to equal 90 degrees. So realistically, always a right triangle, right? This point right here, A, B, C, A is 90 degrees. B and C both have to add up to 90 degrees. Okay? We know that. Of the 3 triangles shown in the above diagram, the right is the one that is most used most often when solving real-world problems. So the problem earlier was talking about her trying to find the kitten on the house. A house is always, the outside paneling is most of the time it's just straight up and down, right? And then the ground is congruent with that. It goes along with that. So we have a right angle right here, right? So this would be the ladder in that example. So we have the house right there and then the ladder right there. The type of triangle that has characteristics that are unique only to right triangles. So right triangles have characteristics that are unique only to right triangles. Some things will only work on right triangles. Every triangle has 3 sides and 3 angles. We know that. Every triangle has 3 sides and 3 angles. The sides of a right triangle have names that apply only to right triangles. So, in your notes, draw a right triangle like this, right? The 2 sides of the right triangle are labeled A and B. These are called legs of the triangle. So our 2 sides, A and B. The side of the triangle opposite the right angle, so the one that goes along with the right angle, so you could see how every angle has a counterpart. So our counterpart to our right angle is this line right here, the hypotenuse. I've drawn an arrow that points at that. And this is always the longest side of the right triangle, always. The names of the legs A and B can be switched from one leg to the other. So A and B, those we can switch if we want to. But C must always remain the same. C is always going to be the hypotenuse, okay? So C equals hypotenuse. Right? C is always equal to the hypotenuse. The names of the legs A and B can be switched, but C is always going to be the opposite of the right triangle. So, for example, I'm going to draw another triangle here. So we have, just give it a second to load here. So we have C, the hypotenuse is always on the opposite side of the right angle. So you can see the right angle is drawn right here. The relationship between the hypotenuse and the legs of the right angle can be defined by the Pythagorean theorem. My friend, the Pythagorean theorem states that the square of a length of the hypotenuse is equal to the sum of the length of a squared and the length of b squared. So our problem that we're working here, guys, our situation, our equation that we use for this, c squared, sorry, technical difficulties. It'll load in 1 second here. So a squared plus b squared. You guys love technology. I'm sure your Chromebooks are all working very similar to how mine is right now. So we have a squared plus b squared equals c squared. Have you guys ever heard of this before? This is the Pythagorean theorem. So we have, this states that the blah, 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 a squared plus b squared equals c squared. So let's look at our triangle here. Remember, we have A, B, the longest side, the hypotenuse is always C. The equation representing the Pythagorean theorem contains three pieces, which are A, B, and C. If you know these three pieces, of two of these three pieces, then the equation can be used to calculate the third piece. The Pythagorean theorem can also be used to determine any given triangle, if a given triangle is indeed a right angle. So we can use it to see if this is truly a right triangle. We need to look at this triangle given below. There's no right angle marked to indicate that the triangle is a right triangle. Is this triangle a right triangle? The Pythagorean theorem can be used to answer this question. So I'm going to quickly erase this here. So I'm looking right here. A equals 3, B equals 4, and C equals 5. So let's do this math. A equals 3. So we have 3 squared plus 4 squared equals 5 squared. So now let's figure out our exponents, order of operations here. What's 3 squared? What's 3 times 3? 9. Plus, what's 4 squared? 4 times 4? 16. Now, what is 5 times 5? What is 5 squared? It is 25. So is it true that 9 plus 16 equals 25? It is true. So this triangle right here, guys, is truly a right triangle. So we solved that problem. Please make sure that you're following along with your notes here, guys. So both sides of these equation is equal, right? 9 plus 16 equals 25. This triangle is truly a right triangle. So the values of 3, 4, and 5 for the positive integers, a, b, and c, respectively, is a combination of numbers known as the Pythagorean triple, which are a set of 3 whole numbers that satisfy the Pythagorean theorem. Other Pythagorean triples can be generated in multiplying the values of any known Pythagorean triple in any positive integer. If the Pythagorean values of 3, 4, and 5 are multiplied by 2, then another Pythagorean theorem, 6, 8, and 10, is created. So basically what we can do, guys, is there are Pythagorean theorems. We can take these values. We can take, I'm just going to erase. We could take, so 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, right? We can make these 6 squared plus b squared equals 10 squared. So we know that 6 times 6 is 36, 8 times 8 is 64. If we add those together, we're going to get 10 squared. We're going to get 100. Alrighty, so we're actually going to skip along here. If this, my friends, is getting a little too complicated, let me know in Google Hangouts. If you're having troubles, we can come up with an alternative here for you, okay? But let's go along here to this other example. If we know a given triangle is a right triangle, then the Pythagorean theorem can be used to calculate the length of an unknown side of the triangle, which you know the lengths of 2 sides. So if we know what C is and what A is, we can figure out what B is. So looking here at this example, we have 12, 20, and B. So we know what C equals. We know what 12 equals. We do not know what B equals. So what we can do, my friends, if this works, we can do some reverse algebra here. So we know that A is 12 squared. We know that B is B squared, and we know that C equals 20 squared, right? So let's look here. Use your calculator for this. What is 12 squared? 12 squared is 144. Plus B squared equals, and what's 20 squared? What is 20 times 20? 20 times 20. Pause the video here. We know that it is 400. Right? So what is the difference between 400 and 144? Because something plus 144 has to equal 400, right? That would be B squared. So 400 minus 144 is equal to 256. So it would be the square root of 256. Now on your calculator, find the square root of 256. What is the square root of 256, right? Because it's something times itself equals B, equals 256. So in our problem, the square root is 16, okay? Now if this is a lot here, let me know via Google Hangouts and we can find an alternative way to teach this here. So we know that the side length is 16 inches. Now that is the end of today's lesson. Tomorrow we will be continuing on with this. We will go through the examples and then you guys will have a quick assignment that goes along with this, okay? I hope you guys have a wonderful day and we'll see you again tomorrow. All right, guys, continuing where we left off yesterday. Happy Tuesday, my friends. We're going to continue with the Pythagorean theorem. Now, our examples look like a lot. I understand, but I promise you it's not going to be that difficult. Yesterday, we had a problem about Tracy and her missing kitten. She needs to know if the ladder she's using is long enough to rescue her kitten. So we know her house, A, is 3.8 yards. Right? It's 3.8 yards tall. The ladder has to be 0.7 yards away, right? Wish my computer would work a little quicker. But beggars can't be choosers, right? All right, so we need to figure out if her ladder is long enough. So we know what A and B are equal to. We know that A is equal to 3.8 and B is equal to 0.7. So we need to figure out 3.8 squared plus 0.7 squared. We need to figure out what those two numbers are. So use your calculator, multiply 3.8 times 3.8. So 3.8 times 3.8 gets 14.44. So what is 0.7 times 0.7? 0.49. So if we add these together, 14.44 plus 0.49, right? Because A squared plus B squared equals C squared. That gets us 14.93. So what is the square root of 14.93? This is going to be difficult if you do not have a calculator that can find out the square roots. I believe your Chromebooks can. So you need to use this little symbol, right, to figure out what the square root is. Or if you're using an Apple calculator, you can turn your calculator so it's in landscape mode, and you can calculate out the square root. Alrighty, so we know once we figure out what times what equals 14.93, we know that C has to equal 3.86. So A squared, 3.8, or 3.8 squared plus 0.7 squared equals 3.86. So let's look at example 2. That one was a lot, wasn't it? So let's look at example 2, my friends. So we know what our hypotenuse is. We know what C equals. C equals 34. A equals 16. So we know, we'll let it load here. We're trying to figure out what B is equal to. So A squared, which is 16 squared plus B squared equals 34 squared. So let's figure out the digits that we do know. What's 34 times 34? Pause the video, use your calculator if you need to. 34 times 34. It would be 1,156. That is equal to, what's 16 squared? 16 times 16 would be 256. So 256 plus B squared equals 156. Now, what is the difference between 1,156 and 256? Alrighty, so 1,056 minus 256 is 900. So it has to be the square root of 900. B equals the square root of 900. So what times what is 900? What times what is 900? What times what is 9? It is 3, so we add the 0, right? So B equals 30. Nice job. All right, let's look at example 3. I think that might be our last example. I think we're going to skip examples 4 and 5 today. Bum, 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 bum. if this loads. There we go. So we have 14 and 48. We know that this is A, this is B. We are trying to figure out the hypotenuse, what C is, right? So C, so it's 14 squared plus 48 squared equals C squared. Okay? So 14 squared, or 14 times 14, would get us 196. Plus, what's 48 times 48? 2,304. We add those both together, we get 2,500. So, what is the square root of 2,500? Let's forget about the zeros. What's the square root of 25? It would be 5. So the square root of 2,500, we bring back the 0. Would be, square root of 2,500. Oh boy, I love technology. Square root of 2,500 would be 50. Now, I'm going to teach you how to use a calculator here. Okay. When it comes to Pythagorean theorem, I'm going to link a Pythagorean theorem calculator for you in Google Classroom, my friends. With most math-related assignments, there is always going to be a calculator for you to use if needed. So, Pythagorean calculator. So right on Google, something pops up right here. Now you can either choose to solve for the hypotenuse or leg A or B. Okay, so if we know right here, we're trying to figure out for the hypotenuse, right? We're trying to figure out for C. So we know triangle A is 14, and we know that triangle B is 48. So we can easily figure out that triangle C is 50. Now let's go down here and look at example 5. We're trying to figure out what C is, right? We're trying to figure out the leg B, what leg B is equal to. So we know that leg A is equal to 10. We know that our hypotenuse is equal to 26. Using our calculator, we figure out that B is equal to 24. So ladies and gentlemen, you guys know how to do the Pythagorean theorem. You know that A squared plus B squared equals C squared. But we can always use calculators to help us find the answer too. There's nothing wrong with that. Calculators are used every single day. So you guys will have an assignment on Google Classroom. If you have any questions, you let me know. I'm always available to give you a hand. Have a great day, guys.